Let's talk about how Linux handles storage devices. The first thing we're going to take a look at is a special directory on the Linux system called /dev. And this directory is created by the kernel at runtime, and it's a directory that you really don't need to interact with directly, but we will take a look at it and see what's in it. And what you'll notice is that at the time the kernel boots up, basically what it does is it creates this special file hierarchy under the /dev directory, and that exists because in many cases when Linux interacts with hardware, it's going to interact with that hardware as if it were a file. This kind of just simplifies the way that Linux can handle dealing with data. So if the tools for interacting with a file are similar to the tools that are for interacting with, say, external storage devices, that just makes maintenance of things a lot easier. So what you're going to notice is that this directory is going to be full of various named things that may or may not make a lot of sense to you right at the moment. So let's take a real quick look at this directory and talk about what it does. You're also going to notice that because these are actually files mapped under the root of our file hierarchy, that you'll be able to change permissions, and you could, if you wanted to, read and write directly to these device files. But we're not going to do that. We're just going to kind of look at what the directory looks like. This is the /dev directory, and if you notice, there's a lot of stuff in it. And if we scroll down and we look, there's a lot of things named TTY. There are some things named RAM, but some of these things should look a little bit familiar. You see CD-ROM, something called console, disk, DVD, and basically what these are components created again by the kernel at runtime. And what you're going to notice is that unlike normal files where we'd see an F or directory, or sorry, where we'd see a dash, or directories where we'd see a D here, this specific component has a C in front of it. And if we scroll up, we're going to see at some point some of these items that have the letter B in front of it. And what these stand for are block devices and character devices. And basically what that means is that a character device is going to have data sent to it literally one character at a time, whereas a block device can have data sent to it in chunks. And you'll notice in this case that the CD-ROM on my system, there's this thing called SR0. Notice also that there's another block device up here that's in the disk group, and it is named SDA1. Notice there's also this character device that's in the CD-ROM group, and it's named SG0. And really what's important is these names, and specifically we'll look at the SDA1, 2, and 5, these are the names that each device on your computer is given by the Linux system at the lowest level. This would be the equivalent to in Windows where you have a drive given this letter C or D or E. This is kind of what the system uses, or this is what the system uses to identify the drive at the lowest level. And it's what we're going to use to interact with the drive when we need to do things like format the drive, run file check utilities on the drive, and these are the names that will come up under certain utilities that we'll use to find out things about how much disk space is on our system, and so on. So if you notice in here, the system, based upon information it has and information that the kernel has, goes ahead and just creates this. And you really don't need to worry about stuff that's in here. You just kind of let it do its thing, and right now it's not a concern that we directly interact with this directory. It's just that we know that it's there and what it does. It's important to decipher the information in /dev that we understand how Linux goes about naming devices. And one of the things that's pretty important to understand is that modern Linux systems are still using the underlying SCSI device drivers as the basis for their interactions with USB and serial ATA devices. So they're going to use the naming convention listed at the top that was originally set up for SCSI devices. If you don't know what SCSI devices are, that's fine. Don't worry about it. Just know that most modern hard drives are going to follow the naming convention of /dev. Remember, that's that special directory we just looked at, followed by SD. And if you have one hard drive in your machine, it'll be SDA. If you have two hard drives in your machine, you'll have SDA and SDB. If you have three, it'll be SDC. So the last component here, where the letter X is what would change to indicate the drive you have. If you still have a computer with parallel ATA drives, padded drives, they would have the naming convention HD. But since most modern devices use serial ATA, most of your drives are probably going to look like SDA, SDB. If you have a drive that has multiple partitions on it, that partition is going to have a number behind it. So if you have one drive with two partitions, in this case, you notice that there's SDA, that indicates my first drive in my machine, and the 2 here indicates the second partition of that drive. Let's jump to the command line to take a peek at what this system has available to it. And one of the ways that we can probe our system to see what is available to us is a command called fdisk. And I'm going to use the command fdisk-l. And what fdisk will do is just list all of the drives on my system for me. And so what you'll notice is I get a lot of low-level detailed information about my hard drives. But down here you'll notice that it tells me all of the specific devices that I have on my machine. And this is Ubuntu 12 LTS running on a VirtualBox virtual machine. So what you'll notice is in my dev directory I have a device called SDA because I have one virtual hard drive, but that hard drive has multiple partitions. So I have partitions 1, 2, and 5. And the reason why this is numbered 5 has to do with the way disks get partitioned and the types of partitions that they have, as opposed to in reference to primary partitions and extended partitions. And I'm not going to go into that in this lecture. If that's something that you're interested in, you can definitely do more reading on that. But in this case, I'm going to go ahead and jump back and talk a little bit more about how we can now get some more information about these items. Notice, though, real quick, that it does give you information about how big these components are. It gives you information about the type of file system that it is, and it gives you some information, special IDs that indicate kind of like what the purpose of that specific partition of the device, or that specific partition, is utilized for. We just looked at the fdisk command, and so not only does fdisk allow you to get information about the disks on your system, it also lets you perform low-level operations on your disk. And it's important to mention that the name fdisk is, possibly reminiscent of what you could do to your disk. You could really screw your disks up using the fdisk command, so it's important that you understand its capabilities and that you are careful when using it. And so in this case, if we wanted to find out some more information about ourselves, we could jump into interactive mode to see what fdisk is capable of doing. Now that I'm at the command line, let's see what fdisk can do in more detail. I'm going to tell fdisk to work on my primary hard drive, SDA. And once I hit enter, fdisk/dev/SDA, it puts me into an interactive mode where I can hit M and see all the different types of interactions that I could have with the disk utilizing fdisk. Again, I'm not going to go ahead and do any of these. It's fairly straightforward if you wanted to go in and start to work with the disk. Important things that you can do, add a new partition, delete a partition. You can print the partition table to get more information about the drive, and a bunch of other things. So you use fdisk to partition a drive, and it can be helpful for getting your drives configured the way you want before you utilize them. So if you get a new external hard drive, you get a new USB drive, you can use fdisk to put partitions on it. I would also say stay away from the experts only functionality. And I'm going to quit. So fdisk allows us to partition a drive and get it configured the way we want it at the low level. And once we have a drive partitioned, what we need to do is we need to format the disk to put a file system on there. And the command we use to do this in Linux is called mkfs. And the mkfs command is really just a front end to a bunch of scripts with names like .ext2, ext3, basically scripts that align with the various types of available file systems that we can format a disk with under Linux. It's important to note that when you're formatting a file system, the kernel also has the capability to read that file system that you're developing. In a previous lecture, I talked about kernel modules. It's just valuable that the kernel is going to need to understand how to interact with that file system. And in Linux, the default file system is the ext file system, which is, as of the recording of this lecture, at version 4. But you can also format drives in the Microsoft FAT format as well. One of the things that's important to note is that Linux only supports read-only for the NTFS file system. It's only experimental write access to that file system. So usually when you configure a system, you want to try to stay true to the Linux file systems, and if you need to use a Microsoft compatibility layer, stick with FAT. So let's take a quick look at the man page of this command on the command line. So MKFS, pretty straightforward. The most obvious component that we're going to use is -t to list the type of file system that we want, followed by the device, which is the raw device, like dev/sda or sda1. You would give the name of the device as well as the partition that you wanted to format. And the reason why we're taking a look at the MKFS file system is you will notice that, again, MKFS is really a front end to a number of scripts that understand how to get a disk set up for a specific file system. So in this case, you'll notice VFAT is the Microsoft format, as well as there's an MS-DOS format. So if I wanted to go ahead and format a drive, and I don't have a drive attached to this machine, but we could imagine that I have a drive at SDB. This is all that I would need to do with a single partition, is I would say MKFS, make a file system on this drive that's already been partitioned, give it this file system, and go ahead and use this device as the device that I want to put that file system on. So this idea of having to partition your drive and then format the drive with an appropriate file system. And the two tools you'd use are fdisk and MKFS. To round out the lecture, let's talk a little bit about what you can do if a file system goes bad. There is a command on Linux called fsck, which stands for File System Check, and it's very similar to what some of the programs on Windows like ScanDisk do, in that if you find you have a file system that is throwing errors or has been corrupted or something is wrong with it, you can use the fsck command to actually go ahead and try to repair that volume. It doesn't necessarily mean that it will repair it. It might just break it even more, but sometimes the command can work magic. It's important to note that you can only use fsck on drives that are not mounted to the system. And again, you would just do fsck space /dev/sd, whatever your drive is. So fsck is a really powerful command. It's important that you would read more, but know that that utility exists, and that's what it does. A couple of other things that are helpful when working with drives once you start using them regularly is to know how much free disk space is available on each of your drives, and also a summary of disk usage available for given aspects of your drive. So there are a couple commands. df allows you to see how much space is available, and du allows you to get a little bit more of information about the usage of, say, like an entire folder as opposed to an entire disk. So we can take a peek at these items on the command line. The first command to take a look at is the disk free command. If I do df, it shows me all of the file systems available on my system, and you'll note that the file system mounted as my root file system lists in 1K blocks the total number of available space. I'm a big fan, though, of reading things like a human. So if I do df-h, notice that it shows me all of this information in gigabytes, -h being the human option. So this gives you information about all of the available system, about all of the mounted drives on your system, how much space you've used, and how much is available. The other thing you can do